I'm Caroline Davis, and I'm going to tell you about 3 of the non-parametric tests. So if you're ready, come on in, let's get started. You're going to have to come in because the computer's upstairs. No? What, are you nervous? Oh, these tests are easy. Come on, I promise. Come on over and I'll show you what we're doing today. Like I said, we're going to be talking about 3 of the non-parametric tests. The first one, the sign test. The next one we'll talk about is the Wilcoxon rank sum test. And then finally, the Wilcoxon signed rank test. So let's get started.
There are some advantages to using the non-parametric tests. They can be used to test population parameters when variables are not normally distributed. They can be used when the data is nominal or ordinal. They can be used to test the hypotheses that do not involve population parameters. The computations tend to be easier, and they're easier to understand. Those are my 2 favorites. There are some disadvantages. Larger differences are needed before the null hypothesis can be rejected. It uses less information than the parametric tests. Larger sample sizes are needed to overcome the loss of information. So let's start. The sign test single sample. They're used to test the value of a median for a specific sample. In our example, a high school teacher hypothesized that the median number of students placed in her Algebra 1 class in the past has been about 35 students. She looks back at the last 10 years on her roster and finds the following data for the number of students placed in her class. At the alpha 0.05 significance level, she's going to test her claim. First, we form the hypothesis. Her null hypothesis is that the median is going to equal 35. The alternative hypothesis is that the median will not equal 35. Then she assigns a plus or minus sign to each. She counts the number of minus signs and the number of positive signs. Her test value is going to be the smaller number of the 2. She had 6 minus signs, 4 plus signs. That means that 4 is her test value. Is she done yet? No, not quite yet. She's got to find the critical value. She uses the table in the back of the book, and because it's a 2-tailed test, the critical value turns out to be 1. The rule is, if the test value is less than or equal to the critical value, we reject the null. In this case, her test value is 4, the critical value is 1, so the test value is greater than the critical value. Therefore, we do not reject the null hypothesis. In this case, there is not enough evidence to reject the claim that the median number of students is 35. That's good news for the teacher because she was correct, but it's also bad news because she's correct. Going on to the paired sample sign test, this is used to test sample means to compare 2 dependent samples, such as before and after tests. This time a researcher wants to find out if drinking coffee affects a person's sleep. He asks 8 people to go 1 day without drinking coffee and record how many hours they sleep. The next day they get to drink as much coffee as they want to and record the number of hours they sleep. At the alpha 0.10 a significant level, can the researcher conclude that drinking coffee had an effect on the subject's sleep? The null hypothesis is that there is no difference between the number of hours people sleep when they don't drink coffee and when they do. The alternative hypothesis will be that there is a difference between the number of hours people sleep when they don't drink coffee and when they do. The first thing to do is to subtract day 2 from day 1 and indicate the difference with a positive or negative sign according to the value. Here we have a table that shows the number of positive signs and negative signs. For the test value, there were 7 positive signs and only 1 negative, so the test value will be 1 since it is the smaller value. That's great. Are we done? Not quite yet. We have to find the critical value. We use the chart at the back of the book, and we find that 1 is the critical value. We remember that 1 was also the test value. When the test value is equal to or less than the critical value, we reject the null. Therefore, there is enough evidence to conclude that there is a difference between the number of hours people sleep when they don't drink coffee and then when they do. This is worth noting. When the sample size is 26 or more, use the formula before for finding the test value. Going on to the Wilcoxon sum rank test. It's used for independent samples. The sample sizes must be greater than or equal to 10. Values of both samples are combined and ranked. If the sums are about equal, the null hypothesis will not be rejected. If there is a large difference in the sums of the ranks, the null will be rejected. In our example, a gardener thinks there might be a difference in the number of weed seeds that germinate in 2 major brands of her favorite compost, Super Brand and Duper Brand. To test her hypothesis, she takes 10 separate pint samples from each brand and places them outside. After 2 weeks, she counts the number of weeds that have sprouted in each of the 10 samples from each brand. At the 0.05 level, can she conclude that there is a difference in the amount of weed seeds that germinate in the 2 brands of compost? The first step is to state the hypothesis and identify the claim. The null hypothesis says there will be no difference between the 2 composts. The alternative hypothesis says that there will be a difference. That's her claim. The second step is to find the critical value using Table E. Since we're using alpha 0.05 and this is a two-tailed test, the z-value will be plus or minus 1.96. We compute the test value. First, though, we have to combine the data from the 2 samples, arrange the combined data in order, and rank each value. Breaking down the data, we have the number of weeds found in each of the 20 pots after 2 weeks of growing in a sunny location. Then we put the data in order and rank it. Note that because our groups have the same sample size, we can add either group's rank. We decided to add the Super Brand. When we add all the ranks in the Super Brand, we find that the sum of the ranks is 106. Next, we need to compute the mean using this formula. We substitute our values, and we find that the mean is 105. Next, we find the standard deviation. And then we plug in our values and find the z-score using this formula. Our z-score turns out to be 0.076. When we compare the critical value to the test value, we see that the test value is 0.076. So we do not reject the null because 0.076 is not in the critical region. Therefore, there is not enough evidence to support our claim that there will be a difference in the compost brand. So she can use either the super brand or the duper brand. The last test is the Wilcoxon signed rank test. In this example, the mayor of Jackson wants to find out if the number of drivers running red lights at a busy intersection will change if a traffic camera is installed. A sample of 10 days before the camera is installed and 7 days after the camera is installed shows the number of red lights that have been run. Here's a chart. Is there enough evidence to support the claim at the 0.05 significance level that there is a difference in the number of cars running red lights before and after the installation of the cameras? The first thing we do is to always state the hypothesis and identify the claim. In this case, the null hypothesis is that there is no difference in the number of cars running the red lights before and after the installation of the camera. So, our alternative hypothesis will be there is a difference in the number of cars who run the red light. Step 2, we find the critical value using table K. We find that the critical value is 2. Next, we find the test value. We start by making our table. We find the differences between the before and after variables. Then we find the absolute value of the differences. Next, we rank each absolute value from the lowest to the highest and place them in the rank column. After that, we give each rank a plus or minus sign according to the sign in the difference column. We find the sum of the positive and negative ranks separately. For the positive rank sum, we see that it's 24. For the negative rank sum, we find that it's a negative 3. But then we choose the smaller of the absolute values of the sums. Since 3 is less than 24, 3 becomes our test value. Then we make our decision. Our test value 3 is greater than 2, our critical value, so we do not reject the null hypothesis. So to summarize, there is not enough evidence to support the claim that traffic cameras reduce the number of cars running red lights. And now my study buddy Ryan will tell you about the last 3 tests.
This is Ryan Minton doing his project over the Kruskal-Wallace H-test, the Spearman rank correlation, and the run tests.